Today we are going to start the last unit, that is the AC circuit analysis and graph theory. Till now we completed 3 units. Last time we solved some problem on transient analysis. So here we go. We are starting today the AC circuit analysis and graph theory. We'll discuss phasor diagram, two-port network and graph theory. These three are the main topics of the unit. So come to the introduction to the AC circuit analysis. What is the AC circuit? Here in this unit we will deal with the AC. Till now we were dealing with the DC only, right? Here the first time we are introducing the concept of AC. You people know about AC. The DC current is like this. This is the DC current. Linearly, without zero frequency, F is 0. For this is the DC current. Means I can say the DC current moves like this, in this fashion. But we will talk about the AC currents. The AC currents will be like this. It's changing continuously. Right? On the time scale, it's changing continuously. But repeating cycles are here. See. Means after this completing this cycle, this current is repeating itself again like this. Okay, so we'll talk about this later, but this is the graph for AC. This is the nature of AC, like in one time, in the time period it will change its signs or magnitude. Sometimes it will be positive and then negative. So thus far our analysis has been limited for the most part to DC circuits, those circuits excited by constant time invariant sources. We have restricted the forcing function to DC sources for the sake of simplicity, for pedagogic reasons, and also for the historic reasons. Now come to the point. We now begin the analysis of the circuit in which the source voltage or current is time varying. See, here the source voltage or current is time varying. Means we are talking about AC, right? So in this chapter we are particularly interested in sinusoidal time varying excitation, or simply excitation by a sinusoid. Sinusoid means if you are having this type of nature of any graph, so it will be called sinusoid. A sinusoid signal that has the form of their sine or cosine function. Okay, so don't think that sinusoid means sine wave. No, sine and cosine both are the sinusoid functions. I hope it is clear to you. Sinusoids. A sinusoidal current is usually referred to an alternating current. In short, we called it AC current. Such a current reverses at regular time interval and has alternately positive and negative values. Okay, I showed you like this. This is the graph for the AC current. This is the time varying current, right? This is the positive value, negative value in one cycle. Okay. Now circuit driven by sinusoidal current. Circuits driven by sinusoidal current or voltage source are called the AC circuit. Now come to the point that if we are having this type of graph and we call it the sinusoidal, so what will be the mathematical model of this? So mathematical model, if this is the graph for the voltage, Vt, T is the time varying, V is dependent on the time, that's why Vt, Vm sin omega t. This sin omega t belongs to the graph. Okay, the design of the graph is sinusoid, that's why I am using sin. What about Vm? Vm is the maximum magnitude over here like this. Means if I'll redraw it, so it will be clearly understandable for you. See, I'm taking one cycle over here. This is the max Vm. The graph is of V of t, right? Sorry. This is t and this. So how you will write it mathematically? We'll write it Vt equal to Vm sin omega t. Means you are multiplying Vm with sin omega t, right? So the entire thing will become sinusoidal or sine wave, right? So Vm is the amplitude of the sinusoid, Omega is the angular frequency in radian per second. You know about this. This is the angular frequency. Come to the omega t. Omega t is the argument of the sinusoid. This entire thing is nothing but the argument of the sinusoid. Is it okay? So what are the parameters here? Vm is the maximum current, voltage. Omega is the angular frequency. Omega is the argument. Here the cycle is given. AC cycle, see. Here's second voltage over here, Vt. This is the maximum positive value of the voltage. This is the maximum negative value of the voltage. Right? And this is omega t argument. 0 to pi, pi to 2 pi, like this. So this Vt is clearly Vm sin omega t, right? Because this is the sinusoidal or sine waveform basically. Vm is the max value simply. So friends, see what is the time period. And I think before this we should see this. It is evident that the sinusoid repeats itself every t seconds. Thus t is called the periods of sinusoids. I'll show you here. If you'll observe this sinusoids, after 2 pi it's repeating itself. See, after 2 pi, this portion is the replica of the previous one. So I can say after 2 pi it's repeating itself. So this time is nothing but the time period of the waveform. Okay. This is the time period of the waveform. If you will observe this one, time period t is nothing but, see, this is the time period. T is the time period for the. So when you will compare these two things, if you will compare, so your time will be 2 pi by omega, right? So I can say omega is nothing but 2 pi by t. This is the relation between angular frequency and time period. I hope it is clear to you. Now, a periodic function is one that satisfies ft equal to ft plus n plus t. What it means? It means that if the value of function ft will be equal to the value of function at t equal to nt. Right? See here. In this region and in this region, the cycles are both are same, right? So here is some time, suppose t equal to 1, here is time t equal to 3, means t equal to 1 plus 2, means after 2 it's repeating itself, right? So this we call the periodic function. Okay, these are the basic things. So I hope it's already clear to you people, right? Now let us now consider a more general expression for the sinusoids. This is the more general expression where Vt is nothing but Vm is the magnitude, sine omega t plus phi, where this phi is nothing but the phase difference. Phase difference. Maybe sometimes we encountered with phase differences between two sinusoids. So here we need to represent that phase difference. That's why we are using phi over here. Okay. If you'll observe this, but come here, before omega t plus phi is the argument and phi is the phase. Both argument and phase can be in radians or degrees. See friends, if you'll observe these two waveforms given over here, first this dark one, and the dark one is nothing but V1 Vm sin omega t. But if another, this dotted one waveform is given over here, the shifting is given phi, means the phase difference between, if this is 1, this is 2, phase difference between 1 and 2 waveform is phi given. And if the equation for the second is, the equation is sine omega t. Okay, this is the equation for second one. So what will be the equation for first one? The first one is phi ahead from 2. So the first one will be sine omega t plus phi. Is it okay? Because this is phi ahead of 1. That's why. I hope it is clear to you. Right? Now, come to the question. They're asking, find the amplitude, phase, period and frequency of the sinusoids. We'll see for this. Very simple questions. 12 cos 150t plus 10. Is it okay? So friends, magnitude is clearly visible over here. Vm is nothing but 12 volt. So this is the voltage equation. So this is volt. Now they're asking, find out phase, period, frequency of the sinusoid and amplitude. Amplitude is over. Come to the phi now. Phi is 10 degree. Phi is 10 degree. Correct? But how we'll check this phi? Whether here should come sine function or cos function? You should be thinking. What if you are having sine 50t plus 10? Will you say again the phase difference or the phase is 10? No. You should be having one benchmark. So all cosine functions are benchmark for any calculation. Means if Vt 12 cos 50t plus 10 is given, so we'll see the phase in cosine equation. Means if you are having, instead of this, you are having sine 50t plus 10. Don't directly see this is the 10, this is the phase. No. First convert it into the cos form. And how you will convert sine sine into cos form? You will subtract 90 in the phase. So it will be 50t plus 10 minus 90. Now it will be minus 80. So the phase difference is minus 80 over here. Okay, later I'll come to this point. See this. So here the phi is 10 degree directly. Now come to the frequency part. Okay, if you will compare this by the general equation. So general equation is Vm cos omega t plus phi. Right? What is the omega t? Or what is the omega? Omega is nothing but 50 over here. That's it. This one is over. Now, this is the first question. This is second question. The second one is I'm leaving for you. This is homework to you. You're having here the answers. You can check it, right? Now, come to the third one. In the third one, they're saying calculate the phase angle between V1 and V2. Okay, and state which sinusoid is leading. So I should say you first leading, and okay, we'll come later there. First see this. Come to this question. They're asking calculate the phase angle between V1, value is given over here, and V2, and state which sinusoid is leading. Okay. So calculate the phase angle between V1 and V2, and it's given over here. Okay. Now friends, if you observe this question carefully, so they have given V1 equal to minus 10 cos omega t plus 50, and V2 is 12 sin omega t minus 10 degree. And we have to draw the phase angle between V1 and V2. We have to find out it, right? So friends, if you are going to find out any phase difference or drawing any phasor diagram between two quantities, you should be having these two quantities with same magnitude. Means if they are positive, both should be positive, both should be negative. It should be not like one is positive, one is negative, right? Secondly, the sinusoid waveform should be cosine function, not sine function, because I told you earlier that cosine is our reference. Means means any waveform you have, you should be converted into the cosine form, then only you will proceed. So here this is minus is given. Here I'll not go in mathematics, I think you people know about this. I can write omega t plus 50 minus 180 degree. I can write it because the meaning of this is minus 10 cos omega t plus 50. I hope this is the mathematics part and you know about this. Here all, here sine, tan and cosine. In this all are positive, in this sine is positive, in this tan is positive, in this cosine is positive. Right. So I'll not go inside to this, but you can just, I'm giving you hint so you can remember this, right? So now V1 you converted into the positive form in cosine form, and this is given over here. So V1 is nothing but cos omega t plus, it will be minus 130 degree. Correct? V1 is over. Come to the V2. V2 is given in the sine form, and I told you earlier how to convert sine form into the cosine. Just subtract minus 90. Oh, sorry, 90, right? It is minus 90, correct? So V2 will become 12 cos omega t minus 100, like this. Now we have to come with the phase angle between V1 and V2. Simply it's 30 degree. 30 degree is the phase angle between V1 and V2. If you will draw this, how you will draw? This is 10 omega t minus 130, 12 cos omega t minus 100. Let me draw it. We are getting two equations. 10 cos omega t minus 130, V2 equal to 12 cos omega t minus 100. Correct? So it's like, here is the 0, plus 90, plus 80, plus 270, and this is 360 degree. Correct? Now we have the angle minus 130. So this is minus 90. In this way we have to move clockwise. And here I'll get minus 130, suppose. Okay. So it will be V1 at 130 angle. What about V2? Minus 100. So V2 will be here somehow. It is minus 100. It's minus. What is the difference? They're asking the phase difference. Phase difference is nothing but the 30 degree. I hope this one is clear to you. Okay. Come to the phasors now. This one is the important one. What is the phasor? Sinusoids are easily expressed in terms of phasors, which are more convenient to work with than sine and cosine functions. So instead of sine and cosine function, now we'll use the phasor. What is the phasor? A phasor is a complex number that represents the amplitude and phasor of sinusoids. Okay. See, till now we have seen, if you are having any sine waveform, Vt is given over here. You know the Vmax of the sine wave or sinusoid wave. You can write it. Vt is nothing but Vm sine omega t. Right? This is the sinusoid waveform and the technique to represent in sinusoidal waveform. But here now we have the phasor diagram or phasors, and phasor represents in the form convert directly this form into the phasor form, and phasor form will say the Vt is nothing but Vm angle between them, means angle, phase angle. Okay. So the complex number z can also be written in the polar and exponential form. Means if we are having any complex number, we can represent it in three forms. See, z equal to x plus iy. This we call the rectangular form. Z equal to r angle phi. This we call the polar form. And z r e to the power z theta. This is the exponential form. These are the three forms to represent any complex number, where r is the pose. Now see the conversion. First come to this. Wait a minute. Now if z is x plus iy, this is the rectangular form of the complex number. You can write the same thing, same z in the form of magnitude and angle. Magnitude and angle. Where the magnitude is, suppose you have given the rectangular waveform or rectangular number, you have to convert it into the polar number. So by the help of rectangular you can directly write this. Why? Because this r is nothing but x square plus y square root under root, right? And this phi is nothing but tan square y by x. So if you have given with x and y, can you find the polar form? Yes, you can. See, the rectangular form means individual values are given. X-axis value is given on the x-axis, x is given over here. Okay, fine. J represent the y-axis. This is the imaginary axis. So all j terms will be there on the y-axis, all real term will be on x-axis. So z is nothing but x plus I, y. And you know, if this is the complex number, so x represents a real number and y represents the imaginary numbers. So I'll draw real numbers on the x-axis. Okay. I'll draw imaginary on the y-axis. So this is y. So if this is y and this is x, this is your point z. But this z, you can come from origin to z directly, like this way. So if you'll come directly 0 to z, you need two things. One is magnitude of this line, means r. And the second one is the angle. At what angle you will move to reach to z. So you need two things, r and z. So representation for this is nothing but r phi. Where what is r? You can easily see this. X square, here Pythagoras from x square, Pythagoras theorem will apply here. X square plus y square under root is nothing but the r. R is nothing but root of x square plus y square. I wrote the same thing over here. What is this angle? This angle is nothing but tan inverse y by x. Simple. Right? Now we are having addition, mathematical operations for all these complex numbers. Suppose you have two complex numbers z1 and z2, where z1 is x1 plus jy1 and z2 is x2 plus jy2. You have to add them. Simply you will add the real part. Simply you will add the all imaginary part. What about the subtraction? The same thing. Okay. But if you are multiplying two z1 and z2, two complex number you multiply. So you can't do like this x1 x2 plus j y1 y2. No, this is wrong. If you want to multiply two complex number, you need value in polar form. Because in the polar form z1 and z2 is nothing but r1 r2 and the summation of phase differences of phase angles, summation of phase angles. So if you are having values in the polar form, it's very easy to multiply them. If the things are available in the rectangular form, you can easily add and subtract them. What about the division? In the multiplication and division, the polar form will be best. In the division, z1 by z2, the r1 by r2, and in the phase, phi1 minus phi2. In the division, we subtract the angle. In the multiplication, we add the angles. right? What about the reciprocal? If z is r phi, so what about 1 by z? 1 by z is nothing but this. The r will be reciprocal 1 by r and phi will be come with minus sign, right? Come to the complex conjugate. What is the complex conjugate? See, let me erase it first. If z is x plus iy, the complex conjugate will be x minus iy. What is the magnitude of this? The magnitude of this is nothing but minus phi. So, if you are conjugating, the magnitude will not change, but the phase will change by 180 degree. Means plus will convert into minus, correct? Come over here, sinusoid phasor transformation. So I'll show you what is the leading direction, what is the lagging direction. Friends, I'm taking two axes, x-axis, and on the x-axis I'm taking all real values. On y-axis I'm taking imaginary values. Alright. Leading direction. If something is leading to someone, means it's moving anti-clockwise. Anti-clockwise. If someone is lagging to someone, it's moving clockwise. Is it okay? What it means? It means suppose on the real axis you are having quantity I. Suppose, for example, you are having I on the real axis. And by this arrow, I'm showing V. And if you will observe this V is making phi angle from the x-axis. On the x-axis, I'm having I. And after phi angle I am having V. So I told you earlier that this direction is the leading direction. So here I can say V is leading I by an angle phi. I hope this one is clear to you. What is saying? V is leader. Why leader? Because in this anti-clockwise direction from the reference. So in the anti-clockwise direction we are getting leaders. So V is leading I, yes, leading I by an angle of phi. What about this? In this direction we will get the lagging. Means if here I1 is there, here I2 is there. So I1 is leader and I2 is lagger. So direction will be always counted like this. This is the anti-clockwise direction, leader's direction. Right? So friends, wait a minute. The I is given over here in this graph, making minus phi angle from the real axis. Perfectly fine. V is given in the diagram, making angle phi from the real axis in the leading direction. Perfectly fine. Now, what is V? V is nothing but Vm phi, where Vm is the magnitude, phi is the angle, phase angle. What about I? I is nothing but Im minus theta. This is theta, sorry, not phi. Right? Now come to the expressions. The time domain representation. This is the time domain representation we have seen earlier. This is V equal to Vt equal to Vm cos omega t plus phi. Who is the reference? Cos is the reference, I told you earlier. So now we are converting this time representation in phasor representations. The magnitude will be same, Vm. Simply we will write over here the phase angle. The phase angle is phi, but please be with cosine function. Then check the phase angle. So this is clear, I think. Now in the second case you are having Vm sin omega t plus phi. Vm sin omega t plus phi. I told you first convert it into cosine function. So it will be Vm cosine function omega t plus phi minus 90. I told you, right? Minus 90. If you want to convert the sine function to cosine function, you have to subtract 90 from the phase angle. Now, can you write it now in the polar form? or phasor domain? Yes. Vm is the magnitude. What is the angle? Angle is phi minus 90. They are writing phi minus 90. What about Im cos theta? Cos omega t plus theta. Phase angle is theta, perfectly fine. Im is the magnitude. It's okay. Now come to the sin omega t plus theta. Im theta minus 90. Because the reference will be cosine function. Im cos omega t plus theta minus 90. This theta minus 90 nothing but the phase angle. I hope this is clear to you. Now come to the second one. First question here. Transform this sinusoid to phasor. So given here, I'm taking for you 6 cos 50t minus 40 degree. First check, it's given cosine function. Okay, perfectly fine. So for the cosine function, directly I can write here the magnitude and the angle is minus 40. This is nothing but my phasor form. Very simple. Now come to the B. In the B, they are saying V is minus 4 sine 30t plus 50. So two things are there. You should remove minus sign first, then you should remove this sign sine term. You have to be with cosine term, right? So we'll remove this sign into the cosine and we'll remove this negative sign. So can I write over here, this is, remove this minus sign, 30t plus 50 plus 180 degree. Plus 180 degree means in the third quadrant. 180 plus 5. 180 plus 5. And sine 180 plus 5 is nothing but minus sine 5. So here I'm giving with, I have minus term, means I have this, I converted into this. So I'm just adding 180 degree. Right? Now your function is like sine 30t plus 230 degree. Correct? Now you have to remove this sine and come with cosine. You will subtract 230 minus 90. So this is 4 cos 30t plus 140, if I am right. Yeah, 140. Now, where is the point? What we have to show? Or we just convert into the phasor. So this is nothing but 140. This is nothing but your answer. I hope this is clear to you. Now, wait a minute. Now, this is homework to you. Come to the third one. Using the phasor approach, determine the current IT in the circuit described by the this equation, right? I have to find IT by the phasor approach, right? So in the phasor domain, phasor is nothing but the frequency domain, correct? One is time domain. We are just converting the time domain into frequency domain. It's like transform and something. So in the time domain, the integration represented by j omega in the phasor. The differentiation in the time domain, this operator will be shown by 1 by j omega. Okay. Sorry, I think I am wrong over here. For the integration, you will use 1 by j omega. For differentiation, we will use j omega. Correct? This is the transformation of time to phasor. So here in this equation, we can use it, right? This will be 4i. Fine. Let me erase first. The equation is given 4i plus 8 integration I dt. Sorry, minus 3 di by dt equal to 50 cos 2t plus 75. Is it okay, friends? Come over here. This is 4 plus integration 8 by j omega. Can I write? minus 3j omega. Here d by dt I replace with j omega, and this integration I replace with 1 by j omega. In this side, if you write in the phasor form, it will be 50 at an angle 75 degree. This is cosine function, so directly I can write the phase angle. Now come over here. I is the common in all these three terms. This is nothing but 4 plus 8 by j omega minus 3 j omega equal to 50 at an angle 75. Correct? And so this is I equal to, take j omega LCM, it is 4 j omega plus 8 minus 3 omega square. It will be plus 50 at an angle 75. Now you will keep I this side and remaining will go that side. 50 at an angle 75% multiply with j omega divide by 8 plus 3 omega square plus 4 j omega. Is it okay? Now you can solve this for I. So this is the way in which we will get the value of I. Okay. And one more thing, you can replace this omega actually. Why? Because omega is given over here too. So you can simplify this. I is 50 at an angle 75 into j omega divided by 8 plus this will be 12 plus 8j. Okay, so you can convert this into polar form, you can convert this into polar form, and then you can get I value directly. Final answer will be 4.64 143.2 amperes. This is given in the polar form, right? So I hope this is clear to you. Now come to the phasor relationship for the circuit elements. Circuit elements means if in a circuit, if you are having resistors, in the resistor you have current I, and across the resistor you have voltage V. So what will be the relation between V and I in terms of phasor diagram? See friends, here the circuit is given, I is flowing in the resistor R, and across the R V is given. So V is IR by Ohm's law, you know, right? But if your current is sinusoidal current, means Im sin omega t is the current, or you can take in the reference form, that is cos omega t plus phi. This is the generalized form of any sinusoid function. Alright, so if I is given, can you find out the V? Yes, V is nothing but Ri. So R into Im cos omega t plus phi. This is the constant, and let me write over here Im. I is nothing but Im cos omega t plus phi. So you can check here directly, there is no phase difference between I current and voltage in resistance. Is there any phase difference over here? Phi angle is same, phi angle is same, angle of argument is same, everything is same, only different is magnitude. So if this is the real axis, this is the imaginary axis, and I have taken the current is nothing but Im cos omega t plus phi, means it's making angle phi from the origin, from the horizontal axis phi. Magnitude is Im. Okay, I draw it, and the voltage is V equal to Ri cos omega t plus phi. Means voltage also the same angle, but magnitude is different, and magnitude is more than the current because we are multiplying with R. So both are in the same direction, or they are in path, I can say. Okay, same path. The phase difference is 0. There is no phase difference. If the current is flowing in the resistance, then there is a 0 phase difference between voltage and current. I hope it is clear to you. Come to the inductor now. Here you can see the inductor. Current I is flowing in the inductor L and voltage across the inductor is given V. Now you know the relation between inductor voltage and current. V equal to L di by dt, correct? Okay, give me a minute. V equal to L di by dt, correct? So this is nothing but take current. Current is, you are taking current is nothing but Im sine omega t plus phi, suppose. Can you find out the V? Yes, you can. How? By applying simply or by differentiating, or you can take into the phasor. L is as it is. I told you earlier, d by dt you will write the, what you will write? Omega L, right? J omega. Wait a minute. Let me correct it. Actually our I is nothing but here the cos omega t plus phi, correct? To get V, we'll differentiate it, and where your equation will be minus omega L Im sine omega t plus phi, right? When you will remove this minus sign again, you will add plus 90, right? So this will be finally omega L Im cos omega t plus phi plus 90. See, the current was Im cos omega t plus phi. Here is the current. The phase angle is phi from the reference. Now plus 90. Plus means anti-clockwise always. See, if this is the reference 0, so this way we are getting plus, right? This is plus 90, this is plus 80, plus 270, like this. So this is the anti-clockwise direction. So we need the positive 90. Positive 90 we are getting over here. So here is the V, voltage. Means voltage and current in inductor having phase angle or phase difference 90 degree. So who is the leader, I'm asking you. I told you earlier that see, this is the leading direction. If you are moving anti-clockwise direction, means you are moving to leading direction. So V is leader of I. So I can say V leads I by 90 degree in inductor. Or I can say the current lags, I lags. Current is the lagging, voltage is the leading. I hope this is clear to you. Come to the capacitor. See, capacitor is given over here. The current is I in the capacitor C. Voltage across capacitor is V. Now, the relation between capacitor current and voltage is given over here. I is nothing but C dV by dt. Now, assume voltage equation. Voltage is nothing but Vm cos omega t plus phi. You assumed. You need I is nothing but C d by dt of Vm cos omega t plus phi. You will differentiate, you will get C Vm omega, and this is minus sine omega t plus phi. Again you will convert it. So you will get current is leading over here. C Vm omega cos omega t plus phi plus 90. So this is the current. Voltage is, this is the voltage at phi angle. This is the voltage at phi angle. Current is leading 90 degree to voltage. Current is leading 90 degree to voltage. So in the capacitor, current is leader. Current is leader. And current leads, I can say I leads V by 90 degree. Or I can write V lags I by 90 degree. Is it clear to you? This is very important, because in the upcoming classes we'll use it. Now, relationships. The summary of voltage current relationship. Element R, time domain, Here the time domain, here the frequency or phasor domain. The relation between voltage and current for the resistance is V equal to Ri. In the frequency, the same thing, V equal to Ri. We have seen the phi angle is 0. Now come to the inductor. In the inductor, V equal to L di by dt, right? So d by dt we can replace with j omega. So finally this phi is nothing but j omega Li, right? And j omega is nothing but angle 90 degree. Okay, minus j omega is minus 90 degree. See, the relation between time domain is given over here and the phasor domain is given over here. So here the current is leader, so voltage waveform will be minus 90. Means what I mean to say is, for the inductor V is j omega Li, correct? J omega is nothing but the angle 90 degree, whatever magnitude is over here, the magnitude of this. Similarly, if you are having 1 by j omega c, it means you are having angle minus 90 degree, correct? So I hope this is clear to you. Now come to this question. If voltage V is given, is applied to a 50 microfarad capacitor, calculate the current through the capacitor. Capacitor given 50 microfarad, V is given 10 cos 100t plus 30. So can I write V is nothing but 10 30? Cos is given, yes, I can write. Now what he is asking, he is asking for the current. Calculate the current, right? So current equation is C dV by dt, correct? Or, so in the phasor domain, you can use this formula. V is 1 by j omega c, correct? This is I, not 1. You need to calculate I only. Where is the current? Current. He is asking for the current. Voltage is given over here 10 at an angle 30 into j omega. What is the omega? Here is the omega 100. Okay. What is C? 50 micro. 50 micro. Right? Anything else? No. This is nothing but the current. Everything is come to this side. 10 and 100. See, 10 to the power 3 into 50 into 10 to the power minus 6 at an angle 30. Correct? This is nothing but I. At an angle 30. J is also here. J is means plus 90 you have to add over here. 10 to the power 3 into 50 into 10 to the power minus 6 into 120. I told you in the multiplication, J represents at an angle 90. Okay. So in the multiplication, the angle will be added. So that's why I am writing 120. Now this is the magnitude. Magnitude is what? 5 into 10 to the power minus 2. This is nothing but 50 milliampere. 50 milliampere at an angle 120. This is my answer. So this thing can I write? Come to this side. This thing can I write? 50 cos 100t plus 120 degree milliampere. Can I write this? This is the answer over here. Come to the next topic, and the topic is impedance and admittance, right? What is the impedance? Impedance is nothing but the resistance, but overall we'll talk about. The impedance Z of a circuit is the ratio of the phasor voltage V to the phasor current I, measured in ohms. So for the impedance function, we need phasor voltage and phasor current, right? V equal to Ri. What is the phasor voltage and phasor current? For inductor, V is nothing but j omega Li. For capacitor, V is nothing but I by j omega c. So V by I, this is the impedance in case of R. J omega L, this is the impedance in case of inductor, this is the impedance in case of capacitor. So impedance is the complex function. So I can represent by R plus Jx. And the admittance, what about the admittance? The reciprocal of the Y is nothing but the admittance. Now come over here, you can recall it. The element R, impedance is nothing but the equal to R, admittance is nothing but 1 by R. Perfectly fine. What about L? For L, Z is J omega L. This Z I can say the inductive reactance also. This is nothing but 1 by J omega L admittance. What about C? Z equal to 1 by J omega C and Y equal to J omega C. Right? The admittance is represented by Y and impedance represented by Z. Is it clear to you? Come to this problem. Find Vt and It in the circuit shown in the figure. Where is the Vt? Vt is over here. This is the I. This is the AC circuit. See, you can see this circuit is not the simple DC circuit. This is the AC circuit because sinusoidal source function is given. I'll do this for you. Can I write it? 10 at an angle 0. Yes, I can write it. Fine. 10 at an angle 0. I need impedance or capacitive reactance. I do not need of this capacitance. I need resistance kind of thing or resistance equivalent of the capacitance. So can I convert it? Yes, I can convert. The Xc is nothing but 1 by J omega C. If you remember, 1 by J omega. What is the omega? Omega is given 4 over here. What is C? 0.1. 0.1. So this is nothing but 10 by 4J. This is nothing but 2.5 by J. This is nothing but minus 2.5J. So I can replace this minus 2.5J. And the voltage across is V. The same. Current in the circuit is this. Is it okay? Now the question is, find out Vt and It. Vt and It. Can I calculate It now? Yes, I can calculate It. This is no more in time. So this is I 10 at an angle 0 divided by 5 minus 2.5J. Minus 2.5J. So let me clear it first. Minus 2.5J. So the I was 10 at an angle 0, 5 minus 2.5J. So this is the division kind of thing. So we need the polar form in numerator and denominator. So here this is rectangular form is given. So I can convert it. 5 minus 2.5J I can convert into rectangular form, means magnitude and angle, where R is 5 square plus 2.5 square under root. So 25 plus 6.25. Is it okay? So this is 31.25. Am I correct? Yes, this is R. Okay. So this will be nearly 5 point and 6 and something, whatever. Now come to the angle. Angle is nothing but tan inverse y by x. So this is tan inverse minus 2.5 divided by 5. So tan inverse minus 1 by 2. Am I right? So some angle you are getting. So this I is nothing but 10 at an angle 5.6, and this angle, if you calculate, let's take something, and I is nothing but this 10 divided by 5.6, nearly 1.9 at an angle 0 minus 5. This will be nothing but your current. Now you can calculate the V also. Is it clear to you? So this very simple AC circuit, you can resolve it. What you need to take? You need to know about the omega. You need to know about magnitude. You need to convert capacitor into capacitive reactance or impedance of the capacitor. Then simple technique is there. We have learned in the first unit. Apply KCL, KVL, nodal analysis, whatever you want, theorem, anything you can apply over here. Come to the next question. In the next question, they are saying, let me erase it first. Find the input impedance of the circuit in the figure. Input impedance Z in. They are given the figure over here. Assume that the circuit operates omega given. Frequency is given over here. If frequency is given over here, can we convert all inductors and capacitor in the form of their respective reactances? Yes, I can. First, I'll draw the circuit.